So right here we have our two linear equations. We have x prime equals y minus x squared plus 2 and y prime equals x squared minus x times y. And now what we want to do is rewrite it as 0 equals those equations so that we can solve for x and y and find the equilibria. So now we see that x can either equal y or x can equal 0. So first let's see what happens when x equals 0. We can see that it will be y plus 2 equals 0, and then y will equal negative 2. Now when x equals y, we have to factor this out. So first we take out negative 1, and we factor it to y minus 2 and y plus 1. Now we can see that y either equals 2 or y equals negative 1. Now we can draw a conclusion from this that the equilibria are 0, negative 2, 2, 2, negative 1, negative 1. With these equilibria, now what we want to do is make the Jacobian matrix, and we will use our system of equations to do so. So as we know, the columns are the derivative in respect to x and the derivative in respect to y, and the rows are the values from the differential equations. So that gets us negative 2x, 1, 2x minus y, and negative x. Now what we will do at this point is plug in equilibria values into the Jacobian matrix in order to find the individual matrices and solve for the trace and determinant of each of those. So that will get us with 0, 1, 2, and 0. For the next one, once you solve that, it will be 2, 1, negative 1, and 1. Finally, for 2, 2, we'll get negative 4, 1, 2, and negative 2. So now we can finally solve for the trace and the determinant. As you know, the trace is the sum of the diagonal, and the determinant is like the diagonal, the product of the right diagonal, the product of the left diagonal minus the product of the right diagonal. Sorry. So there we have our answers. Right here we have the unstable spiral, the stable node at 2, 2, and a saddle point at 0, negative 2, and that's the phase portrait.